In the previous lesson, you learned how to factor quadratic trinomials, but in this lesson, we're going to look at quadratics, but maybe if we have a quadratic binomial, how we can factor it. So looking at this first one, we have x squared minus 25. We can really rewrite this so it is a trinomial. It's really x squared plus 0x minus 25, and then we can factor like we did previously. So I can use my x. I'm going to multiply AC, so this is negative 25, and I'm adding to make 0. So then we would list out our factors of 25, which are 1 and 25, and 5 and 5. Well, the only way that we're going to get 0 is if we have a positive 5 and a negative 5 as our factors. So now we can use our box to factor. We're trying to make x squared plus 0x minus 25. We know it's going to be 5x and 5, so that's going to go inside our boxes. Negative 5x, those add to make 0, and then to get the outside, we take the GCF of the top row. We have x squared and 5x, the GCF is x, so this is going to be x. This is going to be positive 5 and negative 5, so then my factors are going to be x plus 5 and x minus 5. So that one was pretty straightforward because luckily with our factors there weren't that many, but let's take a look at the second one. What I forgot to say in the previous one is we forgot to look for a GCF, but there was none. So looking here between 4 and 25, since no number goes into either, we don't have a GCF. Just like the previous one, we can rewrite this as 4x squared plus 0x minus 25 to make it a trinomial like we're used to seeing. And then we're going to do the same thing. So we're going to factor using our x in our box. So multiplying AC, negative 25 times 4 is negative 200. Negative 100. And then we're adding to make 0. So just like the previous one, the only way that we can add to make 0 is if these numbers are the exact same numbers with opposite signs. Well, the only numbers that multiply to make 100 that are the same number is going to be 10 times 10. So this is going to be negative 10 and positive 10. So then we have 4x squared plus 0x minus 25. We have positive 10x and negative 10x. And then getting our GCF, so 4x squared and 10x, 2x is our GCF. And then working backwards, 2x plus 5 and 2x minus 5. So our factors are 2x plus 5 and 2x minus 5. So if you look at these two solutions, there's something interesting about them. They're almost identical except that they're opposite signs. That is because this is a special type of quadratic. It's called a difference of two squares. So a difference of two squares means that the first term is a perfect square and the last term is a perfect square. So for instance, x squared is a perfect square, 25 is a perfect square. Same thing here, 4x squared is a perfect square, 25 is a perfect square. It is separated by subtraction, which is where the difference comes from in difference of two squares, and it factors into two identical binomials with opposite signs. So here are my identical binomials with opposite signs. So looking at this one, once you are able to recognize these, it makes it a lot easier to solve. So 81x squared minus 49, well, 81 is a perfect square. And so is x squared. So the square root of 81x squared is going to be 9x. And then this term is also a perfect square. Square root of 49 is 7. So our factors, our solution, is going to factor into two identical binomials with opposite signs. The first term is going to be 9x. The last term is going to be 7. So 9x plus 7 and 9x minus 7. The second example, first thing we should check for is GCF. So between 20 and 45, 5 is my GCF. So then we have 4x squared minus 9. And then looking at what's left inside the parentheses, 4x squared is a perfect square. We can take the square root of that, and that's going to be 2x. Same thing with 9, that's a perfect square. The square root of that is 3. So my solution, remember to bring the GCF out in front, two identical binomials with opposite signs, 2x plus 3 and 2x minus 3. Oops, I just realized I accidentally wrote 3 out here, but this should actually be 5. All right, so now that we've done that, now we should be able to recognize these pretty easily. X squared minus 49, square root of x squared is x, square root of 49 is 7, and then opposite signs. The second one, square root of x squared is x, square root of 144 is 12, opposite signs. If you're looking at this and noticing that they're not perfect squares right off the bat, that could be because there is a GCF, and in this case, the GCF is going to be 2. So we factor out the GCF, and this is what we're left with. And then inside the parentheses are perfect squares. Square root of 9x squared is 3x. Square root of 16 is 4. Again, opposite signs. And the last one, check for GCF. There is none, but these are both perfect squares. So two identical binomials. Square root of 25x squared is 5x. Square root of 36 is 6. Opposite signs.